Yeah, I think we can get started. We have enough folks joined us. So hello everyone. My name is Raghav Yadav. I'm an Apache Pinot contributor, and I'm working as a staff software engineer at StarTree. I welcome everyone to this Apache Pinot Year in Review 2025 and Look Ahead meeting. Uh, Last year has been an amazing year for Apache Pinot community in all. Community has seen a tremendous growth in terms of both users, contributors. We also included new committers and a PMC member, and a lot of new features across the board. Inquiry engine, Pinot Core, enterprise readiness, and we added a new time series engine. So a lot of amazing work has been done, and in today's presentation, we will start with how the community is going, how each one of us can help to grow the community further, and then we'll look into a few use cases from our OSS users, and then we'll deep dive into the Pinot features which we have built last year. So let's get started. So we, as of now, Apache Pinot community has roughly 5,800 members on Slack. Last year, we added two new committers, Chris Peck, software engineer from Uber, Sonam Mandal from LinkedIn, and we also Gonzalo was added as a PMC in Apache Pinot. So huge round of applause for all of them. So there was a lot of developer activity across the board. There were almost 120 active contributors, 60 new contributors were added, and roughly 2,000 commits were done. Around 400K lines were added, a lot of lines were deleted as well. And looking at the number of Docker pulls which were done shows like how the community was really engaged and how the Pinot was really downloaded and used by the users. We have 6,000 GitHub stars. So a lot of activity, developer activity in the Pinot community. Uh, Next is like how each one of us can help the community grow further. So I would like to invite everyone to participate more in the code PR reviews, participate more in the design discussions. If you have any feature requests, feel free to create a uh, Jira ticket for it, create a ticket for a feature request. If you see any inefficiencies in the documents, please improve the documents. If you have any wins, success stories, which you want to share with the communities, feel free to blog. If you want to host a meetup, please engage with the community and you can get a lot of amazing speakers to talk and be a champion in your organization and be an advocate for Pinot. And we all know that what an amazing job Pinot can do. And as more when more data is coming in and the requirement of real time comes in, Pinot becomes very handy. More and more participation in Slack channel and other social forums where we can ask questions, we can answer questions, organize local meetups. If you have any ideas, feel free to reach out on the Slack or shoot us an email. And any help or any advice needed will definitely be provided. You can share your story, any Apache Pinot story at the link provided. So far, we have seen around 8 million media impressions. We have roughly 5,000 plus followers on X. It's growing, and we have seen 300 plus new this year. So if you have not followed us yet on X, so it's a good time to go and click a follow button on X. And Apache Pinot, we all know, has been adopted by multiple companies and Fortune 500 and 1,000 companies. And here are a few mentioned companies, and you can see NVIDIA, Goldman Sachs, and uh, like we will hear from Angel One, we'll hear from Slack and Walmart today, how they are using and what their story is. So as you can see, like adoption is across the board and which is very evident in the next slide, which is like by the sector. So retail is heavily using, fintech and banking is using, food and logistics. We have a DoorDash, Grab, and this is not only in one country the across the countries. Media and communications. We have a cloud native and SaaS companies like Wix and Slack. So yeah, adoption is like across all the sectors, and it's very amazing to see how the usage is growing and new use cases is coming up, and that's where we all can kind of contribute more to the community as well as help each other wherever required. So now with this background, now in the next section, we would like to hear from our OSS users, their success stories, and how they are using and what benefits they have seen, and if they have anything to share. So first, I would like to invite Sai and Jebin from Slack to share their success story. So over to you, Jebin and Sai.
Hey, thanks, Raghavendra. Hi, everyone. My name is Sai. I'm a data engineer for the Admin and Trust Insights team at Slack. And joining me today is Zebin, software engineer from data infra team at Slack. Next slide, please. Thank you. So yeah, together we're going to talk today about how we use like Pinot at Slack, and specifically how we use like real-time capabilities of Pinot for a very recent customer-facing use case for real-time analytics that we launched in Q3 of last year. Yeah, we've been using Pinot at Slack for more than 3 years now to empower our customer-facing dashboards and analytics use cases, and most of these analytics have been like batch-based. So we have like Pinot offline servers and offline tables that we have been using to serve these use cases, and the data is like kind of often delayed by 24 to 48 hours since they're like batch-based analytics. But very recently, in Q3 of last year, we released our first external user-facing real-time analytics use case at scale to a very large number of enterprise customers of Slack. And to set some context, like this project came into existence because most of our like enterprise customers did not have visibility into how much data, specifically like how many messages and files from their like Slack's instance are being exported out and are being consumed by external Slack apps. And for us, it's a big visibility gap to our customers because it pertains to security, and we wanted to like make them understand how their data is being exported out from Slack by these apps by providing them visibility through real-time analytics and insights. And as you can imagine, real-time data is like really important for this use case because it gives the ability for our customers to react to these consumptions as they're happening at the moment, rather than like know about that as a fact after it would have happened in the future. And like I said, we've used Pinot to empower this feature. And yeah, with the help of Pinot today, we are able to like ingest more than 400 to 500 million records into Pinot at real time with a data landing latency of less than 1 second. Meaning, like if an app has requested for a certain number of messages from a Slack's instance, the corresponding event would be seen in Pinot in less than a second. And on top of it, we are also able to like query this huge volumes of data at query time with a query latency of less than 10 seconds. And the aggregations that we would perform are also like really compute intensive. We want to like show distinct number of like messages and files that would have been consumed by these apps. So we wanted to like distinct count on multi-value fields, on arrays and stuff. So that is like very huge compute intensive problem, but Pinot helped us solve it with Pinot native like distinct count HLL and distinct count HLL MV functions, which provides the approximate counts using hyperlog algorithm on like these huge volumes of data. Um, yeah, we've also like done a bunch of tuning. We have scaled our infrastructure, and we've added like so like indexes like range sorted and inverted index to our configs to be able to meet this level of like scale. But yeah, everything like kind of worked, helped us launch this out. Next slide, please. So yeah, with this, we are able to like address a very big gap for our customers and like provide them the visibility into like the data that they needed to act upon. And with the foundation that we have set up last quarter and last year, we are now like very confident that Pinot will help us add more and more real-time analytics use cases. We have also like recently working on onboarding Flink at Slack. So like together with Kafka, Flink, and Pinot will solve most of our real-time analytics needs, and that is going to be a big focus for us in 2026. We'll be working very heavily on adding more and more real-time use cases. And yeah, you might see myself, Zebin, and Nirja, another data engineer from our team. Yeah, talking about and asking questions in the open source Slack channel as well. And as we figure out more details. But yeah, I'll hand over to Zebin to talk more about the infra at Slack.
Yeah, thanks, Sai. Next slide, please. Yeah, so this slide shows the diagram how we achieve this solution in the infra layer. And in this diagram, the green line represent the data flow, and the origin line represent the query flow. So on the left upside, you can see when the Slack users interact with the Slack web app, the data will flow into our data warehouse. Previously, we already had the dev part, which is the batch job. So every day during the night, the data will flow through Spark into S3 and ingested into Pinot offline servers. However, the limitation for this solution is that we have about 1 day of data latency, which gradually doesn't satisfy our existing users' monitoring. And that's why we started exploring the real-time solution, which is on the right side. And with the real-time solution, we ingest the data into Kafka services directly. And on the bottom, you can see that we are using the real-time Pinot real-time server to consume all this data. And with these new components of data flow, we reduce the data latency from 1 day to about 1 second. And this is a big achievement to improve our user experience and also achieve a lot of additional business use case. Next slide, please. Yeah, and thank you so much for inviting our team here to share our stories. Yeah.
Yeah. Thank you, Sai, and thank you, Jevin. So next we have Milind from Angel One and Anand to walk us through their real-time analytics at Angel One. Milind, over to you.
Yeah, hi, I'm Milin Chaudhary. I'm presenting on the behalf of Angel One. So Angel One, the capability of Angel One for handling so much high capacity of loads and providing such fast query times has really helped us shaped a lot of our business verticals, and it has helped us solve many of our problems which were previously very difficult to solve. So please, next slide, please. So in Angel One, we have many business verticals. It's equity, future and trades, commodities, loans, insurance, and B2B, B2C, and many other verticals. And each of the verticals have their own requirement, their own set of analytics, and their own set of monitoring and decision-taking panels. So Pino has helped us chase all in all those verticals in different use cases. Next slide, please. Yeah, so these are some top use cases or top business verticals that Pino has helped us shape a better output out of them. So first is consumer experience. So consumers use our app for stock trading and other stock activities. So now consumer gets a personalized view using Pino real-time databases and query where he can see his recent activities, and he can see personalized options to him based on trend and popularity. So that's calculated in real time, and it's personalized for each user and each user behavior. So it has helped us shape the entire view that the user gets, and entire experience that the user gets, and getting the most ROI out of it. Next slide, please. So Grip is our notification system portal. So in Grip, there are many type of campaigns, promotional campaigns, marketing campaigns that are communication being sent to users. And In these campaigns, we require very quick data to make quick decisions and get the best output out of it. So we have a real-time dashboard in Grip, which helps the campaign managers to take instant decisions based on the data. It also helps us to detect anomalies that are present throughout the campaign, and rectifying it as soon as possible. It's manual as well as automatic. So we also have a phased campaign mode where we have multiple phases in campaign, and each phase only gets executed if the previous phase has reached its performance threshold. So this automatic behavior has helped us lessen down the user fatigue and get the most returns out of the investment that we make here. And in the Prism is our user onboarding panel. Here the user has too many steps involved in is the onboarding journey. It's KYC, it's registration with stock exchange, and many other things. At each step we have a clear visibility and clear monitoring, where we get to know where the user are dropping off, where we are getting an anomaly or not. And it help us get alerts if we are facing any kind of issue. And in Prism, we also have a self-healing system powered by NiFi, working upon Pinot database, that if it detects any issues with user, it automatically performs a workflow which set of instructions which try to fix those problem automatically, and user gets onboarded very quickly without any manual intervention. Next slide, please. So in Pinot, we are dealing with a huge loads of data. These are just optimistic number. Actual numbers are even more. So we are dealing with around 100K peak TPS ingestion, 2 million queries per day. Both of them have increased around 50% more. Five different tenants, which are five different business verticals, and P99 for user facing analytics, all of them under 100 milliseconds. And the average is even lower. Next slide, please. So we have also contributed in Pinot code base, primarily by Anand Shaw. So he has helped us improve the correctness and accuracy of group by queries. He has helped improve multi-tenant support in Pinot, and he has also contributed to roaring bitmaps repo. This is a technique for querying databases, and it's not only used in Pinot, it is used in other databases as well. So and also allowed the benefits to reap in Pinot code base as well. So these are the contributions by Angel One. Uh, Next slide, please. Yeah. So the capability of Pinot to handle so much load has enabled us to build some features on real-time database that have cost us even higher for us without Pinot, and it would have taken a longer time to implement without Pinot. So we also have very future scopes of Pinot. We have just started this a year ago only. So now we are planning to shape our entire business in many verticals through powered by Pinot. Yeah, thank
Uh,
you.
yeah. Thank you, Milind, for walking us through how you use Pinot. Next, we have Arshina from Walmart to walk us how Walmart uses Pinot and what are the use cases. Over to you, Arshina.
Yeah, hi guys. I'm Arshana. I'm working as a staff engineer in Walmart. So primarily we are using Pinot in our last mile delivery system where you are actually delivering orders from stores to customers, right? And then that particular life cycle where you have like 20, 30 plus microservices involved, and everybody is maintaining a state of one entity, in this case which particularly is order. Pinot becomes your one stop for figuring out what the life cycle of that particular entity is, and then that allows everybody to analyze how any order or any entity is moving between from one system to other, and overall what's the state of that particular order in that life cycle is. It also helps with your anomaly detection and monitoring. So you actually know exactly where and which system uh, the issue is happening, and it's the Pinot helps us reducing the resolving time, right? That by almost 50% because of that, because that becomes like a one stop where you can figure out any kind of gaps that you have between multiple last mile delivery systems, and that happens in real time. It also, we have created multiple business metrics and that enables us to have fast analysis on whatever the systems have been going through, and then and improving the investigation, and then figuring out that what next steps needs to be followed. We have couple of AI agent driven insights as well, where we are we are just tuning and tracking and making it better, that we are making sure that automated uh, resolving of the issues also happens as part of that. So that is something that we are working on right now. Next slide, please. So right now, what our ingestion sources are mostly Kafka and Cosmos. In Cosmos, where we are tracking the change feed, and those transformations happens through an application which is feeding data into Pinot, and then using that data, we are creating multiple dashboards and alerts and monitoring for across the last mile system. Um, Primarily, we are using for dashboarding Superset and Apache Airflow for any kind of alerting, and not just alerting, right? We are just resolving issues. So these are all automated resolving issues as well. And that uses, very less developer time, and then it gives us easier one stop, we know exactly where the issue is, and involving only those teams. Next slide, please. Yeah, thank you. So right now, in Walmart, Pinot is deployed on GCP, and as I mentioned, we are using Superset and Airflow for analytics. Um, we are creating new agents where, agent and bots where which we can help with, which can be used by anybody to just search with any kind of order, and where is my order and how it's going on. We have, if looking at the stats, right, we have around 50 plus tables, and that's still increasing with more services coming to Pinot, and then giving to have a better life cycle view. And in future, right, what we are trying to do is to have better AI agents to integrate with Third Eye, and then, right now it's only limited to US markets, but we are planning on introducing Pinot to the international markets as well. I think Canada and Mexico is already in place. Um, so yeah, thank you so much for inviting Raghav and Mayank. So and the community support has been really awesome. Thanks, guys.
Yeah. Thank you, Ashina, and thank you all the VSS users so far walking us through the use cases and sharing their experience. So now we'll move on to the features. Last year, the major features which we have added to Apache Pinot and the review. So we'll start with Query Engine. So Yash and Shaurya and Praveen are going to walk us through. So over to you, Yash.
Hey, thanks, Raghav. Hey all, my name is Yash. I'm a committer on Apache Pinot, the open source project, and I'm a software engineer at Startree, primarily working on the query engine aspect. So I'll kick us off with the features we've added to the query engine. So this year in 2025, last year, we added hundreds of commits to the query engine across new features, bug fixes, enhancements, and I'll try to go through some of the most interesting ones. So we added a lot of performance improvements, but just to pick a couple, one was a long known gap with performance on order by descending, where the performance was surprisingly not up to par as compared to order by ascending, especially on sorted columns. So that's a long known gap that has now been plugged. Another cool new thing is we added group trimming to the multi-stage engine, which is something that existed in the single stage engine for a while and is super powerful to protect servers from going out of memory or running into any kind of memory issues on high cardinality group buys. So that's another thing that's going to improve performance on the query engine, particularly group bys in the multi-stage engine. Then talking about observability, again, added a lot of stuff here in various areas like better error reporting, better error messages, better logs, better multi-stage engine stats. So query stats for the multi-stage engine are super important to be able to understand what exactly is going on with your complex query, what the bottlenecks are, what could be optimized, where exactly time is being spent. So we spent some time improving these stats so that it's easier for you to debug and understand, exactly where your queries can be improved. And we added like a graph-based visualization for this, where you can very easily and clearly see exactly where the time is being spent while executing your query. Also added a flame graph and added a bunch of new stats, including GC and CPU per stage, so that you can find out exactly what stage is bottlenecking, both in terms of memory and CPU. Talking about stability, again, lots of new things in this area. Just to name some, we added query throttling for the multi-stage query engine to protect servers from excessive resource usage. And this throttling is just going to overall improve the stability of the system. And counterintuitively, we've actually seen the throughput actually increasing through throttling, because we are able to sort of prevent too many queries competing for resources at the same time, and we are actually able to improve the overall throughput as well as stability of the system through smart query throttling. We've also improved how we are using gRPC and netty across both the query engines, and again, this is just going to lead to overall better stability as well as improved query performance. Yeah, next slide, please. I'll talk about some of the join improvements as well as aggregations and window function improvements we made in the query engine. So in terms of joins, we now support a distribution type hint to allow broadcast joins. So this is going to be super useful when you have like one really large table being joined with a really small table. In this case, you could use hints to avoid this large table from being shuffled altogether. And that's just going to make your join a lot more performant because a lot less data needs to be moved. Then we also support local replicated joins with local exchange parallelism, which is going to be useful when you again have small tables that are fully replicated to all servers. In this case, you can avoid data shuffle altogether. And finally, we also now allow co-located joins on tables that have a different number of partitions, as long as the number of partitions are like a multiple of the smaller number of partitions. So you might have noticed a common theme here. All of these join improvements are actually trying to reduce the amount of data being moved or the amount of rows being shuffled. And this common theme is because the biggest bottleneck in distributed joins is IO. So whatever we can do to reduce the amount of IO being done is going to massively boost performance for these joins. On aggregations and window improvements, we added support for polymorphic aggregation functions, which was a long time missing feature in the Pinot query engine, where the same aggregation function, let's say sum, can return a different type based on the input type that it is actually aggregating. So this is a powerful new feature that we added for aggregations, and slowly we will have more and more aggregation functions support this new polymorphic framework. Then we also added various new aggregation and window functions, and we added null handling support for various aggregation functions, primarily targeting like multi-valued aggregation functions, which didn't have this functionality already. Yeah.
Yeah, hey, I can talk about the MSc Physical Optimizer. So I'm Shaurya. I am a senior software engineer at Uber and like a contributor at Pinot. So yeah, just to give you an idea, basically for the physical optimizer, when you write a SQL query in Pinot, the logical planner basically builds a relational algebra tree, right? With joins, filters, aggregations. But that logical plan has no idea about your physical reality. So it doesn't know how your tables are partitioned. It doesn't know which server holds which segment, and it doesn't know if two tables are co-located. So it produces a correct plan, but not necessarily an efficient one for your actual cluster. So here is where the physical optimizer comes in. The physical optimizer, Pinot applies a series of distribution aware transformation rules. And these rules look at partition metadata, segment placement, and worker topology, and then reshape that plan accordingly. So, one big area where it shines is eliminating shuffles automatically. Suppose two tables are hash partitioned on the same key with the same number of partitions. Without physical optimization, Pinot may still insert a hash exchange and reshuffle data before the join, which is expensive network I/O. The physical optimizer, however, detects this collocation through partition metadata and skips the shuffle. Each server joins its local partition directly, and that turns a cluster-wide distribution into parallel local joins. So without query hints, we've had these legacy query hints like in MSC is partition by group by keys, where we had to let the optimizer know that it's already partitioned by group by keys to remove that exchange, which physical optimizer does automatically. Then second is aggregation pushdown. So for a query like grouping and counting, instead of shipping raw roads upward to upstream stages, each server now performs partial aggregation locally, and then the optimizer inserts intermediate aggregation nodes and converts functions to their merge forms, like count turning into sum during merge. Also, based on the data distribution, it can decide to even skip the final aggregation. Because, for example, if your group by keys are like if a table is already partitioned by the group by keys, it doesn't really need to aggregate, it doesn't need to reshuffle and aggregate those at the merge, like at the upstream node. And then thirdly, intelligent worker assignment. So the optimizer uses Helix metadata to assign leaf stages to the servers directly, which actually hosts the segments. It understands partition parallelism, multiple partition per server if needed, and then places intermediate workers based on distribution requirements like hash, broadcast, or singleton exchange, which is different from the default optimizer. Also, it supports server pruning. If like it filters out, if certain filters eliminate certain segments, only the relevant servers participate in the execution based on the servers involved in the child nodes. There are some current limitations, which are no spool reuse of common stages and no dynamic filters for semi joins. But even with that, like the impact is significant. Yeah, next slide, please. Another extension of the physical optimizer is like the MSC light mode. So you can think of it as a middle ground between single stage engine and the multi-stage engine. So on one hand, light mode runs on top of the multi-stage engine, so it supports advanced SQL features like joins and even window functions, which are not currently supported in the single-stage engine. But at the same time, light mode follows the same scatter-gather principles used in SSE. Instead of building a fully distributed execution graph, light mode simplifies the topology by making all non-leaf stages run on a single worker, often the broker if run broker config is enabled. So this means less network shuffles, less coordination, and a simple execution model. However, this simplicity comes with trade-offs. So light mode is limited by data in a way that full MSC is not. So in MSC, data can be free partition shuffled across workers. In light mode, it's all happening on a single node. So memory and correctness is a limitation here, but that is a trade-off for the reliability you get for the MSC, right? And one of those safeguards to avoid more memory usage is like an implicit limit on tables being read, right? We add a limit on the leaf stages so that we cap the amount of data which we are pulling up, so which ensures that the single worker handling the non-leaf stages is never overwhelmed. So this is pretty good for queries like dashboards, top-end queries, and exploratory workloads, cases where we expect the results to be bounded. So yeah, next slide, please.
Hey, thanks, Shaurya. I'll continue from here. So, as of join is a cool new kind of join we added to Pinot. This is super useful when working with time series data. So, a very common use case is a financial use case where you could be joining a stream of trades with a stream of market quotes. And in these sorts of cases, we don't want to do a typical traditional join where you're only able to join rows with an exact matching key. what we actually want in these kinds of cases is to be able to join rows that have the closest match on a particular column, typically a time column. So in an as of join, there's typically two phases. The first phase is similar to a regular join where we are doing a distributed matching, and this is going to be using an on clause similar to a regular join. So, for example, in the financial case, the on clause might be the ticker symbol of the stock, whereas the second phase, after we already have matches based on the on clause, we will have something called a match condition in the SQL, where using an in-memory search based on a built-up hash table and some tree sorted trees, we'll actually for each row in the left table, we'll find the closest match in the right table on the specified column, like I said, typically the time column. And this closest match can be defined by the user in terms of whether the left side should be greater than the right side, greater than equal, less than, or less than equal to. And we'll basically be able to get this sort of joint stream where each of the closest matches will be joined together, unlike a traditional join where you can only get exact matches on the join keys. Another typical use case for this kind of as of join is in IoT and sensor data analytics. So in IoT analytics, data from different sensors often arrive at unsynchronized intervals. So an as of join can actually correlate these disparate streams. And that's just another typical use case for as of join, which is super powerful for working on time series data. Yeah, next slide, please. So the next kind of the new next feature we added is this unnest or cross join unnest. It's again a super powerful feature that is a standard SQL feature which wasn't present in Pinot up till now, where we are able to unnest array or multi-value columns and cross-join it with the row that the array belongs to. So looking at this example right in front of you, a simple example where we have like this long array column type in the result set. If we do a cross-join unnest, we can actually explode this result set where there's a row multiplication being done. Each input row is being converted to n output rows based on the number of elements in each of those arrays. And this is a really powerful construct that can be used for performing various different kinds of analytics on multi-value or array columns. So this new feature actually really tremendously improves the usability of multi-value types and array types in the multi-stage engine. Yeah. Next slide, please.
Next is Praveen.
Yeah, hello folks. So I'm going to talk about three improvements which we recently made that kind of address real production challenges for us at LinkedIn. So the first one being the introduction of virtual data source. So we had this problem when like even a new column was added, some queries like select star used to fail during segment reload. And this was primarily because the Pinot server and the Pinot broker had a different view of the schema. So the way kind we address this is to unify that view and also to create on the fly virtual columns. And this allowed us to have zero downtime schema updates for this operation and also to make sure that the queries that we're running previously didn't break. The second improvement which we did was on the smart HLL. So we use distinct very frequently at LinkedIn for most of the analytics use cases. The predominant one being the post analytics use case. So if you like post something on LinkedIn, then you kind of get the aggregated view on like different locations, different job titles and all that. So what we found is for very certain niche power users, like say for example, Bill Gates is trying to view the analytics of his page. This was taking very long time. For example, the distinct in itself was taking around 20 seconds. The HLL was taking around 8 seconds. So our platform in itself has this time out of 5 seconds, and this in itself taking more than that meant that those people would never see their analytics if they were looking at a longer window. So what we found with the HLL, which we were doing, is we use the underlying data structure as a roaring bitmap. So that in itself is very nice because it kind of dedupes the value, but it was working against us for certain users which have high cardinality. So people like Bill Gates and all that, we had segments where the value was greater than like 10 million and the cardinality itself was very close to 7 or 8 million. So the roaring bitmap was working against us. So we added this optimization to just do HLL for those columns. So there was a trade-off on accuracy versus the performance, but for those kind of power creators, it was okay to trade off with that percentage of accuracy. And those people saw like a very boost of improvements. Like the queries used to take about 8 seconds, now they complete within 1 second. The third improvement is the any value. So any value is very commonly used across multiple SQL languages. So we didn't have this in Pinot. So the idea of adding this was one of the feature requests from one of the user. But later we found that having any value also improved the query performance for the use cases which they were running on. Next slide, please, Raghav. Uh, so I'm going to just give you a sense of like all these three improvements were very niche in nature, like the complexity was not large, but the gains we got out of them was very huge. For example, with the any value optimization, earlier the queries used to consume like say 70% of the CPU. After we added any value for those specific workloads, the CPU utilization went to 30%. For these HLL optimization, the queries used to take as long as 8 seconds. Now they were completing within 7 seconds. And the optimization was very simple. Like you switch the database, which was roaring bitmap for the smart HLL, to just do direct HLL for all the values. And for the virtual data source, the idea was just simple, like both the brokers and the servers should be seeing this same schema. And once we hit this condition where the mismatch was happening, we created the virtual column for those source and cached it. Yeah, so that's pretty much it. Thank you for your time, folks.
Yeah, thank you, Shaurya, Yash, and Praveen, walking us through all the improvements and features added in Query Engine. Next, we have Shaurya walking us through the new cool time series Query Engine capability in Pinot. Over to you, Shaurya.
Yeah, thanks, Raghavendra. So the time series engine was originally introduced to enable native support for PromQL, M3QL, KQL, and similar time series query languages directly in Pinot. So this is important because metric workloads are inherently high cardinality and demand low latency. So Pinot, it's a natural fit. So, however, like while time series engine could execute queries, it wasn't ready for general availability. There were several gaps that prevented real production adoption. So, firstly, the response format wasn't broker compatible, which made it difficult to integrate seamlessly with existing Pinot infrastructure and tooling. So, the current experimental API which we have was based on the Prometheus API. So, it's like totally different from the broker response which we get from for the regular SQL queries. Second, you couldn't easily query or visualize time series results through the controller UI. And thirdly, it lacked operational maturity. Things like query stats, query options, and query event listeners and explain plans were either incomplete or missing. So this basically meant limited debuggability and observability. So what we did for the general availability, and we are targeting general availability by Pinot 1.5, is that we introduced a new post query time series API that returns a broker response compatible payload. So this ensures that you can simply use the same mapping, like the response is something which is very expected, and you can seamlessly switch between the query SQL and the query time series endpoint. On the usability front, we also added a dedicated controller UI page for querying and visualizing time series queries. And you can see the new query page on the right image. So we added a visualizer, and we also added, like a whole lot of query stats around it. And this chart view is very dynamic, and it can be resized and moved across. So it's very interactive. And then from an operational standpoint, we also build robust exception handling and comprehensive query statistics by propagating server-side metadata through the time series block up to the broker. So like we can see like which like this query, how many segments did it exactly scan, and additional metadata. So this basically enables the proper query stats reporting, error visibility, and sets the foundation for query options as well. So that any custom time series implementations can basically define their custom behavior through these query options, which are not tied to Pinot specifically. Yeah. So this is basically the general availability work we did. Feel free to check it out like in the controller UI. Yeah. Yeah. Thanks. That's from my side.
Thank you, Shaurya. Yeah, moving on to Pinot Core. So first we have priority pool routing by Sean. Over to you, Sean.
Hi. Yeah, I'm Shay. I'm a senior software engineer from Uber. Um, so today I'm gonna introduce the priority pool routing strategy. So at Uber, the stateless service already support the end-to-end canary isolation. Essentially, each service um, I mean like we were first to get into context why we need this priority pool routing. So the context is here is like at Uber, the stateless service already support the end-to-end canary isolation. And essentially each stateless service would place a few nodes in canary zone, and the deployment goes to the canary zone first. Um, in the query traffic uh, issued from the canary zone at the very upstream layer consists 2% of the total production traffic. So we call this traffic as canary traffic. And the network teams will guarantee the canary traffic and the normal production traffic are totally isolated, as shown in the left bottom charts on the left side. And each stateless surface can monitor the performance of the canary zone and auto trigger the logout, pause, or rollback. In this way, when a user onboard, I mean, in this way, when if there's any like a bad logout, it will be detected early instead of directly rolling out to other zones and impacting the normal 98% of production traffic. However, the Pinot system is onboarded through the stateful service. So due to the historical reasons, the stateful service doesn't natively support the this safety mechanism. So when the user onboard a very heavy query shape, it the it would touch many. I mean, it would touch every Pinot brokers or Pinot servers, and it can cause a global blast radius incident. So our goal is to mitigate this global blast radius. Um, um, and the key question is like we have to answer is what kind of data isolation model we should use to support this query isolation. Shall we support the uh, data in partition level? I mean, shall we? Yeah, the answer is not because like most of Pinot queries are aggregation queries. So even if you do the data isolation at the partition level, meaning you put a specific partition data to a subset of nodes, it wouldn't work because the aggregation query would hit every partitions, which means you will touch every partitions. So there's no isolation there at the partition level. So the rest of tries to do the data isolation uh, is to do it at the replica level. So at Uber, we'll place different replicas into different zones. Um, so right now we already figure out the data isolation model. Then the query isolation solutions is much straightforward. So here is the flow. Um, as you can see on the right side of the left bottom chart, um, so there's a change on the query gateway. You can see that the carry nodes of the query gateway would only route the traffic to the Pinot broker canary nodes. And the query gateway would also add a special query tag called preferred pools. In our case, we will select the pool 0 as the destination of the canary traffic. So we will set the data number to 0. And then the Pinot broker would receive that query. For context here, the Pinot each Pinot brokers they have a mapping, they have a cache mapping from uh, the segments to the number to the server instances. So once the Pinot broker receives that query, it would perform a different routing strategy. Basically, it would just choose server instances in the pool 0 per segment. And ideally, all of the kind of traffic would be routed to pool 0. In this way, as you can see, the blast radius is reduced from 100% to the 50% to 50%. So more replicas, the more blast radius reduction can be done. And as you see on the uh, on the right side, there's a metric showing the effect of the canary traffic isolation. So for canary traffic, the traffic is limited to the pool 0 most of the time. And for the normal production traffic, it's evenly distributed to pool 0 and pool 1. So I assume that there's only two replicas as a demo purpose. And you might notice there's a traffic burst in the canary traffic chart. And I think that the date is around November, sorry, the May 15th, no, May 7th, May 17th. So the reason is because there's a node version upgrade. And because the canary traffic is part of production traffic, so we want to ensure the query successful ratio instead of fail it directly. So we will route as traffic we will route traffic to several instances in pool 1. So you can consider this routing strategy as a best of efforts basis. But I mean, like even if it touches pool 1, it doesn't like cause the blast radius because we only route the traffic to pool 1 service corresponding to like pool 0 pool 0 node which are being updated. So basically, in other words, you only touch several nodes instead of all, especially for the large data sets. And actually, the version upgrade frequency is low, so I think in the overall sense, the blast radius like it would not be global. Yes, that's pretty much on my side.
Hey, Raghav, do you want me to present or
Yes.
no, go ahead, keep going. Yeah.
Yeah, sorry, I got disconnected. Thank you, Sean. So next we have real-time ingestion. I have a small request from the speakers because we are running out of time, so please keep it short and concise. So next is Tarun, who will walk us through upsert efficiency improvements.
Thanks, Raghav. Hi, everyone. My name is Tarun. I'm software engineer at Uber. So at Uber, we have a lot of use cases that heavily uses upsert functionality, where we have use cases where, for one particular primary key, there can be up to 18 or 20 updates. Think of a trip where at every stage or every status of the trip, we update that metric, right? So that's just one scenario where we can have a lot of update. But we have a lot of use case around this. So two of the biggest challenge that we faced with any upset workload was, first of all, it was the segment fragmentation. So over time, when we have a very large retention table, which is also an upset table, we saw that we had a lot of segment where even though it only had very few primary keys that were valid in the segment, But since even if there is one primary key which is valid, we cannot delete the segment. We ended up with a lot of segment which contain very less information. We had upsert compaction enabled on this, which means there wasn't any disk pressure, but overall the segment count was quite high. And what this does is during every query, we need to scan all of these segments. So it increases the segment process and segment meshed and everything. And it basically increases the scatter latency for our queries. And it also increased the ZK pressure because there were like a lot of segment that needs to be managed. So to fix this or to improve the query performance and overall cluster stability for this, we created an upsert compaction task. We called it upsert merge compaction task. So on top of the compaction task, it also merges multiple segment into one. So the current compaction task used to do one segment per task. Now this will pick multiple segments and create one merge segment with data from all these segments. So this drastically reduced our number of segments. We were able to reduce segments up to 3x or 5x. And what this meant was we were able to we were able to improve the query performance by 40 to 60%. And we were also able to support higher retention values because earlier we were restricted with number of segments that we can manage in a cluster. So we had to keep a low retention period and then user would re-ingest their data to keep their primary keys alive. But with this, we are able to support infinite retention because we can continuously keep merging older segment and keep the overall number of segments in check. So yeah, that was a small segment merger task that we contributed. The second one is commit time compaction. So this feature tackles the stale records during the commit issue. So in Pinot, whenever we are creating a segment, we always commit the entire segment. So say for a particular primary key in a consuming segment, there were 5 updates. We will persist all 5 updates on the disk. And later we rely on upset compaction or upset merge compaction to actually delete those older 4 records because those are stale record and are not being used. Which means at the commit time, we are wasting our CPU, IO, and disk storage to process these stale records, which are never going to be queried. So solution for this was to improve our commit protocol to add one more step to basically filter out all the invalid records before committing. So we rely on in-memory bitmap, which is Validoc ID bitmap, to know what are the records that are still valid and only persist those records into our immutable segment. So basically, from a mutable to immutable transition, we exclude these records from the immutable segment and also rebuild our indexes, our directory, and everything before committing on the disk. The impact for this was quite high. We enabled it for some of the use cases. We saw that the segment commit time reduced by about 75%. This also means that we get risk reduction out of the box. We don't need to rely on external upside compaction or merge compaction tasks to reduce disk. And yeah, overall, this has increased the freshness SLA for us because now we were able to reduce the commit time ingestion delay that we were seeing for some of the larger tables. Yeah.
Yeah, thank you, Tarun. Next, we have pauseless dedupe upsert.
Folks, my name is Aman and I'm giving a brief that's the review. So we wanted to push the boundaries of real-time ingestion and ensure that we have the best freshness possible. So we introduced pauseless ingestion for that. As we know, during during an ingestion, real-time ingestion, we have a consuming segment that once it reaches a fixed threshold of rows or size, it has to build. And during the build time, we have a pause and ingestion, which can last up to between 5 to 10 minutes. We wanted to remove this pause and continue the ingestion meanwhile the build was happening. So what we did was we allow the server to create a new consuming segment for the controller to create a new consuming segment and allow the server to ingest data for this new consuming segment Meanwhile, the previous segment is being built in the background. Now, this obviously introduces a bunch of reliability issues in the sense that what if the build failure fails? What if a commit protocol fails? We added all those checks and balances and also introduced the ability for the controller to trigger re-ingestion on one of the servers in case none of the replicas were able to build the segment, and we want to re-ingest those missing events that contributed to the segment that was being built. Along with this, along with reliability and performance, we really wanted to ensure that we expand the functionality with which for all the things that we can use pauseless ingestion with. And for that, we expanded it to dedupe. Now, dedupe becomes tricky because ordering becomes important in case of dedupe. And given that we are building another segment in background and ingesting a new segment in parallel, it can end up happening that you ingest new events and the build segment build of the previous segment fails, and you end up in an inconsistent state. So for that, we introduce a consumer coordinator that ensures that whenever we load segments on the server, we load them in the right order. We added few disaster recovery modes, as I explained before. This helped us ingest around 300K events per second and ensuring that the freshness stays within 5 seconds. Given that we were pushing the boundaries of ingestion, we saw issues with the current throttling model that we have, which is message based in the sense that we always rate limit the tables to the number of messages that we can ingest. This unfortunately does not take into consideration the size of the messages or how much in memory or memory pressure would ingestion introduce. So for that case, we introduce byte-based throttling that smartly checks what the size of the messages are and then figures out when it needs to throttle once a byte threshold has been hit. That's all from my side. Thank you.
Thank you, Aman. Next, we have resilience and stability improvements. Harnoor, over to you.
Yeah, thank you, Raghav. So my name is Anur, and I work at Star3. So yeah, I will be just talking a brief about the resiliency and stability improvements we did for real-time ingestion. So yeah, this is a very brief and concise view of what we did over the last year. So starting with the first one, so we used to see a lot of consumer dead issues in Pinot. So basically, the ideal state for consumer will say consuming, and the external view will also say the segment is in consuming state, and the ZK metadata would be like in progress. But the consumer thread but there would be no consumer thread in the Pinot server, like there would be no consumption happening. So we fixed this edge case, and we made sure that whenever consumer thread dies, it informs the controller, and controller marks the segment into offline state. So that the real-time segment validation job can handle it in the future. So all of these edge cases were completely fixed. And the other race, so there used to be a race condition as well in the stream consumer. So basically there is for example, a Kafka consumer would be utilized by a consumer thread. It would be used by the debug APIs, consuming segment info API. So all of them will share the same Kafka consumer object. So, and the Kafka library will throw like concurrent access, modified exception whenever there is a shared access. So we fixed that race condition as well. So yeah, moving on to the second, eliminated ingestion deadlocks installed. So as Aman mentioned, we we added the feature pauseless ingestion, and the scale of ingestion increased tremendously, and we were ingesting a lot of events. So at such a high pace, the super rare edge cases also became like not so rare. So we used to see like many like edge case issues which will happen in very rare scenarios. And so there was like, for example, there was a deadlock between the consumer thread and then consuming to online transition thread. So we fixed that deadlock, and there were semaphore leak. So at such a high ingestion rate, so there were like multiple consuming transition threads, multiple consuming transitions in line. Like, uh, for example, a slow server scenario, a lot of consuming transitions for multiple, like let's say 4 segments were in line at the same time, and there would be some log contention. So we added a consumer coordinator to fix the semaphore leaks. So moving on to the third issue. So we hardened failure handling and improved the real-time segment validation manager job. So basically, so manual intervention, any manual intervention required to fix any real-time ingestion issue. So we try to automate all such cases using the real-time segment validation manager job. So for example, the resetting of an error segment is by default run by real-time segment validation job. And so we basically build a matrix. So for a given segment, so it can be in three states across idle state, external view, and segment ZK metadata. So we build a matrix and table and listed out like all the cases uh, in which a segment can be, and we made sure that all the cases are covered in the RVM job, so that no manual intervention is required, and RVM job can automatically fix the issue. So yeah, moving on to the next kinesis ingestion. So most of the cases were handled for Kafka, but in kinesis, unlike Kafka, so uh, a partition can split and merge. So there were some corner cases we saw that the ingestion used to stop when such an event will happen, like a kinesis shard will split or merge. So we have handled such cases as well. And yeah, and moving on to the last point, so optimize offset lag tracking. So so in the consumer thread, so the way offset lag logic is that it used to be in the consumer thread, it will pull the latest offset from the upstream, and it will subtract the last consumed offset, and it will report the offset lag. So all of this, like polling the latest offset, will happen inside the consumer thread. So let's say if polling the latest offset takes like 4 minutes, so for 4 minutes the ingestion will be stopped for that partition. So we move this overhead outside of the consumer thread, and we added all the offset lag tracking inside an async thread. So this helped us to reduce the consumer thread overhead, and helped also fixing a lot of edge cases which were causing incorrect lag metrics. So yeah, these are like some of the brief points which we made to improve the stability in the real time ingestion. So yeah, thank you.
Thank you, Anuj. Moving on to batch ingestion. So next we have a performance and reliability improvements. Over to you, Kishan.
Krishan is not here, so I'm Manish. I am from Startree, talking on behalf of Krishan. He's also from Startree. So continuing on the stability theme, I'll talk about two improvements in the batch ingestion, and both are in the segment process framework, which is the foundation for batch ingestion. The first one is in the segment generation path, where when you have like a lot of no dictionary columns of high cardinality, the segment generation consumes memory heap, and sometimes even runs out of memory. Actually, ohms, you've seen ohms. The bottleneck here is we store the unique value during the stats collection, and the optimization was to use the HLL to get use a probabilistic data structure to get the cardinality, and that significantly reduces the memory as well as the segment generation time, as you can see, right, from 5 minutes to a couple of minutes, like 1.5 minutes. So this one was a big improvement, and the correctness also was taken care of. The PR actually has details as well. So that is in the segment generation part. The second one is also segment process framework, and that's in the mapper phase, where we do the transformation and partitioning. So here, what happens is that a minion task gets the input files, and oftentimes it happens that the files are heavily compressed, and when they expand, when we do the mapper, it goes 50x or 100x, and we run out of disk, right? So here we have an adaptive disk usage guardrail, where we track the disk utilization while the mapper phase is happening. And when it reaches a certain threshold, say 80% or 90%, then we stop there and then we generate the segments, clean up the disk, and iteratively do the next map and segment generation. So this will prevent the minion from running out of disk. So these are both are the segment process framework, which is used by many ingestion tasks. Thank you. Yeah.
Yeah. Thank you, Manish. So next we'll move on to enterprise readiness section. First we have Om production. So Jackie or Chinmay, if please take it over.
Yeah, I can quickly talk about it. So we recently added this was added quite some time ago, but this was recently refined for accuracy. So we now have a way to enforce automatic query killing, the three levels that we use: alarm, critical, and panic. So in critical, if the heap memory goes above a certain threshold, 96% is the default, it'll kill the most expensive query, and in panic, it'll kill all. So this is currently heap-based ohm killer. It is being used in production in a few cases, pretty stable right now, and it's being used to make sure we don't fail the servers, which was the previous case.
Yeah, thank you. Moving on to broker, gRPC server, and client support. Chinmay, do you want to cover? I think Shang is not able to join.
Sure. Yeah. So there's a bunch of improvements made on the gRPC support for on the broker side. Improvements on the compression, introducing the ZSTD standard. Arrow integration was another support here, and then block size tunings and things like that. So this is for those who haven't used this, gRPC gives you the streaming semantics for querying Pinot. So this is yet another way of querying Pinot in addition to the REST API. There's lots of improvements made here. Next one.
Yep. So next is Jehao.
Okay, this is Jehao from StarTree. And so for table rebalance, we have been observing some efficiency and as well as like a lack of observability, because this is a really heavy operation. It introduces a lot of traffic and pressure on servers, so a lot of time. It used to be a pretty painful experience to do table rebalance. And because of that, we tried to improve the observability, and then we added some guardrail to this operation to improve the stability as well. So the first thing we added is the pre-checks. It tries to catch the common pitfall during the table rebalance operation beforehand. So when you're trying to do the table rebalance, you run a dry run, and the pre-checks should be able to catch some common pitfall to catch the problems before you actually runs it. And feel free to contribute to this, like to if you have some if you discover some issue in table rebalance, and that's you think it might be able to catch it beforehand. Feel free to add it to the pre-check list. And then on the right-hand side, we have summary. It's also a pretty helpful preview when you do the table rebalance dry run. It compares the ideal state for you so that you don't need to go into the ideal state and see like what is changing. It has server level information, it has segment level information, and it has like the tenant level information. So you can compare it to see if that's the expected run you want to do on the table rebalance. And then once you run the table rebalance, we have a better view of the table rebalance progress. So you have a lot of different numbers you can observe of this table rebalance progress. Next slide, please. So for guardrails, we added something to protect the table rebalance from bombarding the servers. So you can still keep the servers running, serve queries despite the table rebalance is in place. So the first thing we added is pretty important, is the batching. So table rebalance used to update a lot of ideal state in one go, and that can cause a lot of state transitions on one server. With batching, the controller knows it can only do this much ideal state update or state transition at one time on one server. So you can try to set it to a lower numbers, for example, like 20. So there will be at most 20 or like necessarily at most 20 state transition on one server during the rebalance. Of course, it makes it slower, but it's safer. And then we prevent the duplicate job. And we have dynamic timeout, so you don't because you don't know like how much time it would take before you actually run the table rebalance. So it's hard to set a timeout, and now you have dynamic timeout, so it would only be timing out if it's actually not making any progress. And we have first commit during the rebalance. This is to prevent um, the consuming segment being moved to a new server, and then there's a lot of backlog in the upstream, Kafka or Kinesis for the server to catch up. And then we added segment operation throttlers to limit how many state transition can do certain operations at the same time. So if the segment itself it needs an index rebuild on a server, without this throttler, there can be too many state transitions to do the segment index building at the same time. That could be a problem because it takes a lot of resource to do that. So we added this to protect this. This doesn't benefit only for table rebalance. It also benefits the server restart, table reset, etc. And then we have some supports on tenant rebalance now. So tenant rebalance is to rebalance tables in like multiple tables at the same time. So it used to only rebalance the whole tenant, but now you can select which table in one tenant you want to rebalance. And then we have automatic job tenant rebalance job recovery. And then you can also cancel tenant rebalance job if there's anything went wrong. So it adds more safety to this operation. Yep, that's it.
Yeah, thank you, Jehao. So next we have summary of Apache Pinot contributor call by Robert. Over to you, Robert.
Thank you, Raghav, and thanks for inviting me for today's call. I'll keep it brief. I know it's raining, coming close to the end of the time. So what are contributor calls? There are sessions just like these where we actually can go into deeper depth into pull requests, recent changes, designed to go, deeper into those topics. Last year, with the help of Yardan and Zhang, we kicked off a new Meetup series along these lines, and we covered 10 different topics over 5 different sessions from April through November, where we were meeting bi-monthly and monthly towards the end. We covered small segment merger and compaction, which we just heard from Tarun from Uber back in November. Aman talked about pauseless ingestion, which he talked about. Sheen came a couple of times, talked about multi-topic ingestion and graceful node replacement. And so all of those sessions are recorded and uploaded to the Apache Pinot YouTube channel. We have a Slack channel where we can talk about upcoming or past events. Feel free to contact myself or Shang about presenting your topic. We typically do like anywhere from 15 minutes to 45 minutes, limited to a couple of presenters or topics per 1 hour meeting. We don't have any sessions planned for this year, but I'm happy to help organize and host those meetings for the community. Thank you.
Thank you, Robert. Yeah, so moving on to the most exciting part, future roadmap. Over to you, Chinmay.
Hey folks, yeah, if you go to the next slide. So these are some of the items that are already being discussed actively. This is not an exhaustive list, of course. The idea is to, you know, get collective feedback from this group and others in the community. If there are more things you want to see on the roadmap, definitely reach out. Would love to, and we'll discuss in the Apache Pinot Slack. That's a good place. But some of these things that are in play, Arrow integration is one. So Uber folks have already started on this journey with Arrow on the ingestion side, Arrow decoder integration. But the broader theme is to even explore a deeper integration with in-memory formats, which will overall makes it more efficient in terms of data copy and query processing. Multi-stage engine, we already saw a bunch of improvements. It's already becoming pretty mature, being used in production in a lot of places. In addition to that, future optimizations include things like system table. So we would be able to improve the observability of historical queries, and be able to understand the pattern of which query is expensive, be able to debug on a single query stack. Along with that is query isolation, right? So today we have ability to throttle queries, have killer in place. Next up in the evolution would be ability to also provide some sort of query isolation on the same table, right? So this may include a version of that might be the sort of the priority pools feature we saw today, but this can go all the way to make sure an expensive query does not impact an sort of SLA strict query on the same table. Moving ahead on the query engine side is a cost-based optimizer. This is definitely an much asked for feature. This is something we will start exploring as a community. And then of course, all kinds of this is a continuous improvement in the integrations for more input sources, BI tools, and language SDKs. Right? That's an ongoing thing. We'll continue to see that. So again, this is just a sneak peek, right? Feel free to voice out if any of this is exciting. Just reach out on the Slack, or if there are more ideas, would be happy to discuss.